When electrolysis of copper sulfate solution takes place using carbon electrodes. Now this is important because we have to study this exact same reaction in a core practical with copper electrodes. Now the copper gets involved in the reaction. Carbon, however, is inert. So a straightforward electrolysis going on here. What change in mass of electrodes would we expect? And use half equations for your answer. Now in copper sulfate, aqueous, we've got copper 2 plus ions, we've got sulfate 2 minus ions, we've got hydrogen ions because it's aqueous, it's a solution. We've got hydrogen ions from the water and hydroxide ions from the water as well. So we've got 4 ions. Now only 1 ion is produced at the cathode and only 1 ion is produced at the anode. Let's do the cathode first. The cathode is the negative electrode. So the cathode, if you like, would attract the positive ions. Opposites attract. It's going to attract copper and it's going to attract hydrogen. Now the rule here is the least reactive is given off. Now copper is less reactive than hydrogen. So the copper ions in the solution, the Cu2 plus ions in the solution, are going to go to the electrode. And once they touch the electrode, they turn into the elements. That's what electrolysis does. It turns ions back into elements. So we've got Cu2 plus aqueous, and it's going to turn back into elemental copper. Elemental copper is metallic copper, so it's a solid. How do we turn a 2 plus ion into a neutral element? The answer is it's got to get some negative charge to balance out these positive charge. Now the negative charge is electrons, so it's going to gain 2 electrons. So at the cathode is gaining metallic copper, so it goes up in mass. Okay, the anode is the positive electrode. The anode, therefore, is going to attract the negative ions, the anions. It's going to attract the sulfate ion, it's going to attract the hydroxide ion. Now, the rule here is if the anion is a halogen, so the halogen group of the periodic table is fluorine, chlorine, bromine, iodine. If the anion is a halogen, that is given off. Okay, now there's no halogen here, this is the sulfate ion. The sulfate ion is not part of the halogen group. So the hydroxide is what's going to be attracted to that anode. The hydroxide, when it touches the anode, turns into oxygen, O2, and water. To balance this out, we're going to need 4 hydroxide ions. It's going to make 2 water molecules and an oxygen molecule. The hydroxide ion is negatively charged, so how does it turn back into these neutral, this neutral element here and this molecule? Answer, it's got to lose that negative charge. Electrons are negative charge, so it's got to lose that negative charge. So the electrons are going to appear over here. 1 hydroxide ion would lose 1 electron, but there are 4 hydroxide ions, so that's going to lose 4 electrons. So at the anode, we've got oxygen gas being given off. That's not going to change the mass of the anode at all. So there's going to be no change in mass. We only get a change in mass if something is plated on the outside of the electrode, like at the cathode, or if the electrode dissolves. Now the carbon electrode is not getting involved in this reaction. It's inert, so no change in mass. All these questions on ayleshamhighchemistry.com.